Hello. Today we are going to learn how to uh, determine whether the composite signal is periodic or not. What is composite signal? Normally, if there are if a single if a signal has a combination of sine and cosine signal, we normally called it composite signal. Okay, for example, xt is equal to sine 25 t. This is a sinusoidal signal, and plus 4 cos 25t. Okay, so this is a combination of sinusoidal and cosine cos signal. So this is this signal, this xt is normally referred as a composite signal. We already know this. Okay, so today we will try to determine uh, any given composite signal is a periodic or a periodic signal. Okay, so before that, I think you can remember that if we have a sine signal, okay, if we have sine signal, let's say x1t, like this, a sine omega naught t plus 5. If we have this kind of sine signal, uh, we prove that this is a periodic signal, and also we have found that the period, let's say it is t1, is equal to omega naught 5 to 5. So we have learned this. Okay, and also I have given a question in our assignment, in your first assignment, to find the period of cosine signal, cos signal actually. Okay, so if we have a cos signal like this, let's say this is omega 1t plus phi 1 or something. Okay, so you have to determine whether this signal is periodic and or not, and if it is periodic, what is the period of that signal. Okay, so you can use the same argument uh, which we used to determine this sine signal is periodic, and the determination for determining the period, the same arguments you can use for this cosine signal. Okay, cos signal. So so if I go to that circle, okay, so I think you may remember that we explain the sine wave, how to uh, originate the sine wave using a circle, no? So if you consider the same circle, okay, these are two diameters, you already know. Okay, so this is the radius, so this is the center of the circle, this is the center of the circle. Okay, so this is the center of the circle, and if the radius is a, let's say the radius is a, so you can remember that if we get any t value, okay, any t value, so sine wave, we get the sine signal as a projection of this point onto this axis, no, onto this axis. And what is the cos wave? What cos wave is the projection of this point, okay, this point onto this horizontal axis. This is the vertical axis and this is the horizontal axis. Okay, so you know by definition, if this is A and let's say this is Y, okay. So in previous case also we consider this length as Y. Okay, don't confuse with this. Okay, for this time also, if we consider this length is Y, okay, so you know that by definition cos theta is equal to, by definition, Y by A, no? Okay, so Y is equal to A cos theta. So you can see that when this participle is moving along this circle, okay, along this circle, the projection of this point will move from here when the point is moving from here to here, okay, from here to here. This projection will move from here to here, to the origin, to the center. Okay, then the participle is moving from here to here, okay, up to here. Then this projection also moving along this horizontal axis, horizontal diameter to this point. Okay, then if the point is moving from here to here, this projection will move from here to here. And if the point is moving here to here, again this projection is moving here to here. So it completes one cycle. Okay, so if we draw the sine signal, we will get this kind of signal. I hope now you can understand this. Okay, so this is if this is t, and if this is, sorry, if this is theta, okay, if this is theta, and if this is y, okay, so you can see that, okay, you can see that when this point is moving along this side, this theta is changing. Okay, so according to the theta, the amplitude y is changing. Okay, so this y will generate a cos signal, no? So you can see that at the beginning, when the theta is equal to 0, okay, 0, this a this a this line is completely on this axis, no? Okay, so at that point a and y is equal. Okay, a and y is equal, and then what is the value of value of y? Okay, if this if the if theta is equal to 0, this y and a are equal, then what is cos theta? Cos theta is equal to 1. No? Okay. So here, when this theta is 0, when this y is 0, okay, when this theta is here, okay, this y is completely equal to a. So it is begin by here at a. Okay, when theta is 0, the y is equal to a. Okay, then when this theta is moving here to here, okay, now this point is moving here to here. Okay, so let's say that this direction, okay, this direction is the plus direction, and this direction is the minus direction from starting at this point. Okay, so when this participle is moving here to here, this point is reach into the center. Okay, that point is reach into the center. So center reach into the center, and at this theta is at 5/2. This distance, this y distance is 0, no, because here when this point is here moving from here to here, at that time the projection is in that center, no? So this y is equal to 0. Okay, so you can see that when it is moving to plus side, the y is gradually decreasing. You can see that, no, this when this theta is moving, the length, this is the y length from here to here, that is the y length, so it is reducing. Okay, so you can see that it is decreasing like this. Okay, and it is come to 0 at 5/2. Okay, and again the participle is moving from here to here. It is still in now this is the reference point. Okay, so now it is moving, sorry, when you are when you are define the direction, okay, you have to use like this. This is the reference point, so you have to measure the direction and length from this point. Okay, so from this point, this side direction we consider as plus, and from this point, this side direction we consider as minus. Okay, I'm sorry for that mistake. Okay, so this is the reference point. We have to measure the distance and direction starting at this point. So from this point, if we are measuring any value in this direction, okay, in this direction, it is plus value. And if we are measuring from this point any distance, okay, from this direction, okay, from this direction, so that measurement will be 0. Okay, because this distance is a vector. Okay, it is a vector, so vector should have a magnitude as well as direction. Okay, okay, so when this participle is moving from here to here, you can see that the y, now y is in minus direction and y is increasing, no, increasing to minus direction. So y is increasing like that. It is increasing to minus direction. Okay, so at this point, when this point is moving here, at this point, this y again equal to a, no, this y, now the y is here from here to here, the length, that length is y, so at that time y is equal to a again. Okay, so it is like this. Okay, so after another 5/2, so here 5/2, another 5/2, that means here the point is 5. Okay, 5, the signal get a value. Okay, so you can see that from here to here again, that minus direction is decreasing, this y is decreasing and come to 0. So like this, after another 5/2, it come to 0. That means 5 plus 5/2, that means 3 5/2. Okay, and again when this point, now the point is here, when it is moving from here to here, okay, so you can see that the y is increasing in this direction, no, okay, that means in plus direction, so y is increasing like this. Okay, and again after 5/2, the y length, so this is the y length. Okay, so this is the y length. Now it is equal to a again, no, so the length of y became a. Okay, so again it come to a like this. Okay, at that time it complete one circle. So what is this point? It is 2 5/2 plus another 5/2, that means 2 5/2 plus 5/2, that means 4 5/2, that means 2 5. Okay, so you can see that the the signal is completed one cycle. Okay, so this is the uh, this is the pattern of a cos wave. Okay, so if we remember the sine wave, it is like that. It is starting from 0 and going like this, and this is the period. No, this is the 2 pi length. If this is in theta. Okay, so this is one circle. Okay, so you know that this theta can be if this point is moving a constant velocity. Let's say that it is omega naught. Let's say that it is omega 1, because here we get omega 1. Okay, so if it is omega 1, okay, so you can see that so omega 1 is equal to t by theta, no? Okay, because it is the omega is a velocity, angular velocity, and that is uh, the angle per 1 minute. If we you can remember that if we define the linear velocity, it is distance per second. So here it is theta, the angle per second. Okay, because this is angular velocity. Okay, so it is identical, but only thing is here it is omega and here it is this distance t. Okay, so you can see that you can define like this. So theta is equal to, you can say that omega 1t. Okay, so you can see that if this omega is fixed, this theta is again changing with t. So we can remove this t and we can put t here. Okay, okay, so again so so uh, corresponding t value will be, as in sine case, you can see that this point will be 5 by 2 omega naught, and this point will be 5 by omega naught, and this point will be 3 5 by 2 omega naught, and this point will be 2 5 by omega naught. Okay, so likewise we will get if we plot it with t. Okay, so in as in a sinusoidal case also, here also omega naught is equal to omega, sorry, omega, let's say it is omega is equal to t by theta, or theta is equal to omega t, or if the time taken to complete one cycle, okay, this one cycle is capital T, you know that 1 by t is equal to frequency. Okay, and again this frequency and omega is related like this, omega is equal to 2 5 f. Okay, so these identity, this is first identity, and this is second identity, and this is third identity. These three identities are valid for both cosine signal and sine signal. Okay, so I think you get idea. Okay, so you no need to consider about this circle actually. If you can't understand this concept, that is okay. So only thing you have to remember that the pattern of the cosine and the pattern of the sine signal, cos signal, pattern of the cos signal, and pattern of the sine signal. So these two picture you should keep in remember. Okay, okay, so I will try to evaluate this cos omega 1 t plus phi 1 is a periodic signal, and try to find it period. Okay, so same argument we can use here. Okay, so you know that the condition for periodic is x x2t. We will take it as x2t. No? So you know that the condition is x t plus capital T is equal to xt. Okay, so if this condition is satisfied, we can say that it is a periodic signal. Okay, so in our case, it is x2 t plus t is equal to x. Sorry, here it is capital simple t, xt. Okay, so if I substitute this t plus t and xt, okay, so this is the signal a cos omega 1 t plus phi 1. Okay, so that is xt. Okay, so it is a cos omega 1 t plus phi 1. Okay, so this is sorry, xt. Okay, x2t, and then x2 t plus t. So instead of this t, we have to substitute t plus t. No? So if I substitute it, a cos, now instead of t, you have to submit t plus t. That is omega 1 t plus t plus phi 1. So you will get this equation. Then if I simplify it further, you can see that this a and this a will be cancelled out. Then you will have cos omega t, omega 1 t plus omega 1 capital T plus phi 1 is equal to cos omega 1 t plus phi 1. So here omega 1 t and phi 1 is there. So here also omega 1 t and phi 1 t is there. So I get them closer. So I can rewrite this as omega 1 t plus phi 1 plus omega 1 t is equal to cos omega 1 t plus phi 1. Okay, so if you can find a value for this term, okay, so if you can find a value for this term that satisfies these two this condition, then you can say that this is a periodic signal, and through it you can find it period. Okay, so so you can see that. Okay, so if we have any value here, theta value here, okay, theta value here, okay, and if this point is moving one cycle from here to again up to here, it is moving to 5 radians. No, it is moving to 5 radians. So after the 2 5, the point is in same location, in same amplitude. No, if it is go through another period, another, so this is one time. Okay, if you go through this circle 2 times, then after 2 5 times you will get the same result. If you if you uh, if you move 3 times, you will get 2 5 3. If you move n time, you will get 2 5 n. Okay, so you can see that as in the sine case. Okay, as in the sine case, uh, cos uh, cos omega t plus 2 5 n is equal to cos omega t. Okay, so this is one. This is the constant. So instead of this omega t, we can put capital T actually. Okay, then you can see that cos theta plus 2 5 n cos is equal to cos theta. So if you see this signal, okay, if you see this signal, this part you can consider as theta. Then here this part is also theta. Okay, okay, so I just take this omega 1 t plus phi 1 is theta, any angle. So this also angle. So you can see that cos theta omega naught t omega 1 t is equal to cos theta. Okay, so please compare this equation and this equation. Then you can see that if this omega 1 t is 2 5 n, cos theta plus omega t is equal to cos theta. So this condition satisfied if omega 1 t is equal to 2 5 n. So using that, you can find t is equal to 2 5 n omega 1. So when you are finding the period, you have to get the minimum value always. Okay, so the minimum value is t is equal to 2 5 omega 1. Okay, so this is the result. Okay, okay, now we go to a now we will see how to determine a composite signal is a periodic signal, and uh, to find its fundamental period. Okay, for that purpose I will get one example to explain you. Okay, so I will get the example and explain you the procedure. Okay, so if we have a signal yt is equal to 2 sine 2 5 500 t plus any value 50, okay, plus 4 cos 2 5 25 t plus 25. Okay, so this is our composite signal. So you can see that this is a sine signal. This is a sine signal. Let's say it is x1, and this is a cos signal. Let's say it is x2. Okay. Okay. So we have identified the we have identified number of terms inside the signal. Okay, inside this yt signal. Okay, then if you consider this x1, so I will write it here. X1 is equal to 2 sine 2 500 t plus 50. So you already know the things here. So this is amplitude, and this is frequency. Okay, this is actually, it is not all are not frequency. This one is actually frequency, and this is 25f, no? So 25, and this is frequency f. So 25f is equal to omega. You already know that. Let's say that it is omega 1. So this is omega 1. Okay, so omega 1 t plus 50 is equal to omega 1 plus 6. So this is our first signal. Okay, so what is the period of this signal? Okay, so you know that for sinusoidal signal, if we have a sine signal like this, sine omega naught t is equal to 2 pi by omega naught. Okay, so please keep remember that this t always, this is the fundamental period, this t is always related with this component. Okay, not with the amplitude and or with the phase. If the phase is there, this phase is not affecting to the period, or the amplitude also not affecting to the period, but only this frequency will affect to the period. Okay, this amplitude and the phase do not affect to the period. Okay, so please keep remember that. So this 50 will not affect to the period, and this 2 also will not affect to the period. Only this will affect to the period. Okay, what is that? This is omega 1. So t is equal to, you know that, 2 5 by omega naught. So already we know that 2 5 by omega 1. And what is omega 1 here? 2 5 by 2 500. 2 500. So if you remove this 2 5 and 2 5, so you will get 100. Okay, so this is the fundamental period of this signal. Okay, and if you consider the other signal, that is x2 is equal to 4 cos 2 5 25 t plus 25. Okay, so this is the cos signal, and it is also same as a sinusoidal signal. I think you can remember that it is a matter of this phase only. Okay, if it is a sine signal, maybe it is a code signal, and it's all depend on this phase. Okay, this phase. Okay, so you know that this is amplitude and this is your frequency f, and this is the phase shift. So you know that this amplitude and phase will not affect to the t fundamental period, only this affect to t. So here it is 2525, that is f, and what is omega? Omega is 25 25 multiplied by 25. So this is the omega. Okay, then what is the period here? Let's here it is t1. Let's say this is t1, the period of the first sine signal. Now the period of the second cos signal is t2 is equal to, in the same manner, it is omega by 25, 25 by omega. So let's say this is omega 2, it is 25 by omega 2, and that is 25 by 25 by 0.25. So it is 25. Okay. This is T2. Okay. And then what you have to do is you have to get, please remember this point also, you have to get the ratio of this T1 and T2. So if I get the ratio of this T1 and T2, T1 is 1 by 100, okay, and 2 is 1 by 25. So if so I have to divide this 1 by 10 by 1 by 25. That means 1 by 100, okay, 1 by 100 is should be multiplied by 25. Okay, so you will have 1 by 4. Okay, so T1 by T2 is equal to 1 by 4. Okay, so you can see that you have two fine integer here. Okay, so you have fine integer here. Okay, so here in this denominator and other things I can't remember. Okay, so anyway, this up and downs, both terms are integer value. Okay, so if these are integer value, we called it periodic signal. Okay, so if this is integer value, okay, this one, but this ratio is in the this ratio is integer value. The up and the down parts are integer. We can see that this is a periodic signal. Okay, so that is the first point. Okay, so this kind of integer, this kind of numbers we called as rational numbers. Rational numbers. Okay, so if you find in internet what is the rational number, okay, let's find rational numbers. Okay, so you can see that. Okay, here you can if you need, you can read this description for more information. Okay, so you can see that normally we consider 0 as a rational number. Okay, so you can see that any number, any the full number without decimal, that is integer, any integer is also a rational number, because we can write it as a ratio. Okay, so that is the rational number. If we can write the number as a ratio with two integer, it is a rational number. So you can see that 7 by 1, the 7 is also a rational number. Okay, the 5 also a rational number, because we can write it as 5 by 1. That means two fine integer up and down, 5 divided by 1. Here it is 7 divided by 1. So 7 is up. It is a integer, and 1 is at down. It is also integer. Okay. So you can see that these are also the rational numbers. Okay. So the opposite is irrational number. Okay. So let's find the irrational number. I think already you now already you should be able to answer the question. Irrational number means if we couldn't write it as a ratio, then these are irrational numbers. Okay. Irrational numbers. Okay. So you can read the description here. Okay. So if you write it as irrational numbers example, I think it is more easy to understand. Examples. Okay. Let's see. Okay. So you can see that these are some rational numbers, no? So if so this is with many decimal place. So here you can't write this number as a two ratio, ratio of two integer. Okay. And also if we consider root 3, it is also irrational, no? Because root 3 cannot be written as a ratio. Okay, but root 4 can be written as a ratio because it is 2. Okay. So let's say it is, if it is 3.5 but 3.5, if it is 3.5, so 3.5 can be written as 7 by 2, no? So it is a rational number. Okay. But 0.33, we can't write it as ratio, no? We can write it as 1 by 3, but it is not exactly 1 by 3, no? It is approximately equal. Okay, so this number we can't write as a ratio, so it is also a irrational number. So I think you have an idea what is, I hope you have got idea what is rational number. Rational number, that means if a number can be written, as a ratio, it is a rational number. Okay. If the number cannot be written as a ratio, it is a irrational number. Okay. So here it is a irrational number. Okay. Irrational number. Okay. So you can see that if you get this T1 by T2, you will get 1 by 4. That means here the 1 is an integer and 4 is also integer. So it is find 1 by 4. Okay. So definitely it is a rational number. So if it is a rational number, if it is rational, this signal is periodic. This signal is periodic. So you can see that T1 by T2 is equal to 1 by 4. Then it is periodic. So how to find the period? So if I equal this, you can see that 4T1 is equal to T2. Okay, actually this is the period for T1 or T2. So what is this equal to? What is T1? And you already know that T1 and T2. The T1 is 1 by 100. So if you get 4 multiplied by 1 by 100, so you will get 1 by 25. So this is the T. This is the T for total signal, 1 by 25. Okay. So this is the way you have to find uh, the composite signal is a ratio, is a periodic or aperiodic signal. Okay. So I will get another example. Okay. I will get another example. Then I hope you will get a more clear picture on this. Okay. So if I take, let's take as xt is equal to 2 sine root 2 by t. Okay. Let's take it as like this, root 2 t plus plus cos 40. Okay. So if we consider this example, so in the same manner you can consider this as the first component and this as the second component, x1 and x2. So if you get x1 is equal to 2 sine root 2t root 2t. So this is the first signal. So this is omega, no? This is omega. This is omega 1 actually. The angular frequency for first signal, this x1. Okay. So what is t1? The period is nothing but 2 pi by omega 1. You can use this as a known fact. Okay. So it is 2 pi by omega 1. So here you will get t1 is equal to 2 pi by root 2. That is root 2 pi. Okay. So this is the period of this first signal. So let's take this x2. So x2 is equal to cos 40. And what is the period? So this is omega 2 and period is 2, t is equal to 2 5 omega. Here it is omega 2 and then it is equal to 2 5 by 4. That means 5 by 2. Okay. So this is t2. So you get t1 and t2. So if you get the ratio of this T1 and T2, you will get the T1 is root 5 and 2T is 5 by 2. Okay, so you can see that this 5 and this 5 cancel out and T1 by T2 is equal to 2 root 2. Okay, so you know that this 2 is 1 by 4 1 something. Okay, so if it is multiplied by 2, it will be 2 by 2.8 like values. Okay, I can't remember it clearly. Okay, this kind of decimal value, but this decimal value you can't write as a ratio. Okay, you can't write as a ratio completely. Okay, so this is not a rational number. Okay, so this is not a rational number, not a rational number. Then what is your conclusion? So this is not a periodic signal. That means it is a aperiodic signal. Okay, that means no any t is there. Okay, so that is the idea. Okay, so anyway, we will see it in MATLAB whether we can see it. Okay, so so if I write the code quickly, okay, so I think now this you may be familiar with this much. Okay, so I hope you can understand this type of simple codes in MATLAB. So in the same manner, you have to define the t value, the t vector, the independent value. So I will get it from 0 to 0.0001 to 2. Let's take it 2. So now I have defined the independent time variable. So if I write x1, okay, so let's say that x1 is 2 cos 500. No, that is our first example. 500, that means 205. Okay, so I will write this as 205 t plus there is a uh, there is certain phase shift. Okay, I can't remember exactly, but you can put any phase shift because it is not affected to the period or uh, periodicity. Okay, the phase is not affected. Phase and amplitude are not affected. Okay, so so this is, I think, sine wave. No? This is the sine wave. Okay, so if we, as I can remember, the cos wave is like this: cos 2525. You know, that means 55 t plus there is also a phase shift. We put, no, let's say it is 50. So this is our so we will take this as x2. Okay, we will take this as x2. Okay, so this is the x2. So now what is our composite signal? It is x12 plus x12 plus x1 plus x2. No, x1 plus x2. Okay, so this is our signal. Then if we plot it with respect to t, this y. Okay, let's see what is will happen. What let's see what is what we can get. Okay, so I run this. Before run, I have to save it. Okay, let's see. Untitled. Save. Yes. Save. Okay. So if I plot this, what is this? X1 is, and yeah, here it's put the capital X. So if I so you can see that this scale we can't hardly see. So if I reduce this, okay, if I reduce it more, yeah, you can see that it is a periodic signal. No? So You can see that like this. Again, this section here, this section here, this section here, this section here, and this point is here, 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 like this, and this point is here, this point is here. Sorry, this point is here, these are the points, and this point is here, this point is here, like this. So you can see that this is a repetitive signal. Okay, so these are repetitive signal. So let's take how can we get that signal. So so I can remember, we put it as root 2, no, square root 2 is QRT 2. Okay, and let's say that this is this also SQRT. Let's say it is 3. Okay, I can't remember the exact. Okay, but if I run this, okay, so you can see that this is not repetitive, no? So you can see that it is going to decay or something, no? So it is not repetitive. If we get some value, see. See, this is not look like repetitive, you know. So here you can see that this point is not equal to this point. Okay, so we can't say that this and this are same. Okay, and this is not equipped with this, and it is not equipped this. Okay, so it look like there is a repetitive pattern, but if you see closely, these values are different value we get. Okay, so this is not a periodic signal. Okay, so I hope you have got the idea. Okay, how we can determine whether the given composite signal is periodic or not, and how to find its period if it is periodic. Okay, so I hope now you can do some question by yourself. Okay, so I have uploaded some question to the LMS, so you can practice that calculation. Okay, practice that problems. Okay, okay, thank you.